This video is on 45, 45, 90 special right triangles. A 45, 45, 90 special right triangle actually comes from a square. So right here, a 45, 45, 90 triangle comes from a square. Because of a square, all of the sides are the exact same, we can say that these legs are congruent to each other on this triangle. This leg is congruent. We will also have a right angle because it is a square. Now, because you have an isosceles right triangle, so we have two congruent sides, that means that our angles opposite those congruent sides must also be congruent. In order for this to happen, these two angles plus 90 have to equal 180. If these two have to be the same, these would have to be 45 degrees. So I can put 45 degrees inside of both of these acute angles. These must be congruent to each other. We have two congruent sides, therefore the angles opposite those congruent sides are also congruent. So that's why a 45, 45, 90 triangle comes from a square. The blank is the blank of the square. The hypotenuse is the diagonal of the square. So the diagonal of the actual square would be the hypotenuse of the 45, 45, 90 triangle. So on this triangle, we have two legs and a hypotenuse. It is a right triangle. Since we have the same legs, we can just name this a leg, and this will be the exact same leg, because they have to be the same. And we know that since this is the diagonal, this is your hypotenuse. Now to figure out the side lengths, if you know that these are the same, you can still use Pythagorean theorem to find the measure of any one of these legs or one of these sides. But it has a special equation to know, and we can figure out the equation based off of the Pythagorean theorem as well. The equation you want to know is the hypotenuse is equal to your leg times the square root of 2. So if we have our leg, if I say this leg is x, if this leg is x, then this leg is also x, because they have to be the exact same, because they are congruent to each other. Therefore, the hypotenuse, if our leg is x, our hypotenuse is equal to our leg times square root of 2. So the hypotenuse is equal to x times the square root of 2. So this would be x square root of 2. This will happen for any type of 45, 45, 90 triangle. So what you do is you take your leg and you multiply it by the square root of 2 to get your hypotenuse. But you can also, if you have the hypotenuse, you can still use this same exact formula, the same exact equation to find your leg. If I know the hypotenuse, I can plug it into the equation and solve for the leg by dividing by the square root of 2. You would have to rationalize the denominator, but you would still be able to solve for your leg. And you can use this with the Pythagorean theorem. An example of this, we'll do a short example of just how you can see that this will happen every time with using Pythagorean theorem. I'm just going to do a short little explanation. If I have a right triangle, and I know these sides are the same, I know that this side is 3, then I know that this side is 3. I know that 3 squared plus 3 squared is equal to x squared. I can say this is x. 3 squared plus 3 squared is 18 is equal to x squared. I want to take the square root of this. 18 is the square root, so if I take the square root of 18, it's the square root of 9 times the square root of 2. Well, square root of 9 is 3, so we have 3 times the square root of 2. That's our hypotenuse, which is my leg times square root of 2. I can do the same thing if I had, these are the isosceles right triangle, and if I said that the hypotenuse was, let's say it's 16. I need to find a leg. If this is x, I also know this is x, because they're the same. So I know that x squared plus x squared is equal to 16 squared. X squared plus x squared is 2x squared is equal to 16 squared is 256. To solve for this, I would need to divide by 2. So x squared is equal to 256 divided by 2 is 128. And now I need to square root this. So 128, the perfect square that goes into this is 64. So I know the square root of 128 is the square root of 64 times the square root of 2. And square root of 64 is 8 times the square root of 2. So I still have a square root of 2 going on here, but if I had simplified and divided by the square root of 2, I would have had to rationalize and I would have gotten the same answer. But either way, I can still find, if I have an isosceles right triangle, I can still find any value on that right triangle because I can still use Pythagorean theorem. So again, the equation we want to know is that the hypotenuse is equal to the leg times square root of 2. This is in a 45, 45, 90 triangle.